In this video, we're going to try to answer this question where it gives us a table building. Now, it kind of looks like the table has already been built for us here, but they actually give us the reactions. So it's a bit misleading, but that's not what's supposed to be misleading about or challenging about this question. So they give me the evidence to build the table, and this is just giving me some extra information. So I'm going to start with gallium ions, gallium 3s, and I am reacting that with silver chloride. So this is a bit of a trick because we haven't seen a question like this in our examples where you would have two reactants or two products. But it's totally reasonable that we could. So this is non-spontaneous because gallium and the silver chloride are a non-spontaneous reaction. So gallium plus 3 electrons becomes gallium solid. And then I've given this here to you partly so that you can figure it out. So silver plus chloride is silver chloride solid plus an electron makes that. So this is a non-spontaneous reaction. Then it says gallium and manganese 2 are non-spontaneous. So manganese 2 plus 2 electrons. This goes below. So this was non-spontaneous and this was non-spontaneous. And then it says palladium 3 ions and silver chloride is spontaneous. So palladium 3 ions plus 3 electrons makes palladium. This is a spontaneous reaction, right? So that's how we're building our table. And I'm my strongest oxidizing agent to my weakest oxidizing agent. And this is reduction half reaction table. Now, I also have some other information here. Palladium, this has a reduction potential of 0.83 volts, and that's a positive value. And that my silver chloride is negative 0.52 volts. So the other two values must be lower than that because these are now in the correct order. So it says, what is the reduction half reaction potential if the voltage of a cell made with palladium 3 and manganese is positive 1.88 volts. So E cell equals E cath minus E anode. And so this is a positive 1.88 volts equals my cathode, which is positive 0.83 volts, minus the E anode. So negative E anode equals positive 1.88 volts minus 0.83 volts. And so that equals, so negative E anode equals positive 1.05 volts. But this is the negative value, so my anode's half reaction is going to be negative 1.05 volts. And that's negative 1.05 volts because my anode is my manganese. So now I know this value. The next question says, what can you say about the relative electric potential of this half reaction? Well, it's got to be between these two values. So I know that it's going to be greater than negative 1.05 volts, and it's going to be smaller than negative 0.52 volts. And so relatively speaking, I've got an idea of what that voltage might be. Question 4 says, what would the new reduction half reaction potential for chlorine to chloride half reaction be if the reference cell was changed from hydrogen half reaction to palladium? So essentially they're saying this is going to be my new reference cell. What's going to happen to the position or the reduction potential of chloride? And so my chloride here is, I've got my chlorine plus 2 electrons becomes 2 chlorides, and the reduction potential is positive 1.36 volts. Well, if my palladium ion plus 3 electrons becomes palladium, becomes my new E cell, that means this is going to become 0. So I'm going to take, what I need to do is calculate the E cell for chlorine and palladium. So my chlorine is going to be my cathode. And so that's going to be positive 1.36 volts reading off of here, minus the palladium, which is positive 0.83 volts. And this E cell for a palladium chlorine cell here, or chlorine palladium cell, is the difference between those things. So I've got 1.36 minus positive 0.83. And so this is going to become positive 0.53 volts. And so if this is 0, this will now be positive 0.53 volts. And the way that works is everything is always in reference to the reference cell. So the hydrogen is the reference cell that's used to determine all of these cathodes and all of these reductions, right? So the reduction potential is based off of like this kind of reaction. Chlorine and hydrogen, the difference between them, that cell would be positive 1.36. But if I shift where the 0 is to up here where it's 0.83, up here, now chlorine is going to have a relatively smaller value compared to this. So this is a smaller reduction potential if we move the reference cell. Hopefully that helps make sense out of this.